Hi, and welcome to the second video in the series of two videos about structs or structures in C. In the first video, we give an overview of the importance of structs, how they're used, in general, how they're defined. And in this video, we're going to walk through a specific code example that shows how a struct describing a phone, a mobile phone, is created. The advantage of actually walking through the code here is that all the typos that appeared on the previous slides in the previous presentation have been fixed. Okay, we're looking at phone.h. Now, we said in the previous video that the definition of a structure should live in its own include file, its own .h file, rather than being just stuck in line in your C code, in your main.c. That's a convention, and it will work if you copy and paste the code directly into one big file. But the reason for this convention has to do with creating reusable code. And when it's the case that multiple files or multiple people need to refer to the same struct, it's much easier if that struct is in its own file, .h, by convention .h, rather than having to be cut and pasted or copy and pasted out of your file into their file. This ensures that the structure remains uniformly defined across multiple files. So let's walk through this. It starts with something you may not have seen before, but the Zybook calls this a guard. This is the protection against multiple inclusion, against the same header file being inadvertently hash included more than once. When that happens, and I'll explain in a minute how that happens, it causes a compile error because you can only define a particular type def once. And if you redefine it later on, even if it's exactly the same, the compiler will bark at you. So the hash indef, phone incl, that says if that name, phone incl, is not defined, meaning I haven't seen this file before, well, define it. So it defines phone incl. So the next time this file is hash included, phone incl will already be included, will be defined. It'll skip all the code down to the pound indef, and nothing will happen. Then I have the type def itself, it's the structure itself. You might ask, why would you ever hash include a header file more than once? It's pretty, you can actually just do it with a pure typo, copy and paste. However, a more common situation is in larger projects where you would have multiple C files, not just main.c, but several different, let's say, library files with functions in them that your main.c uses. If all of those files need to refer to this particular structure, then it is very advantageous to have it be in its own file and be hash included rather than having to copy and paste it into each individual file where you might say, change it in one file and forget to change it in another and cause some really pretty subtle problems. So this is a convention. It's not enforced by the compiler, but it's a convention that's used to structure projects as they get more advanced, because it really helps avoid some problems, particularly if there are multiple authors. So if you worked on a team project and one person wrote A.C, another person wrote B.C, both of you could hash include phone.h, and you would know you had exactly the same definition of this struct, which is important. Okay, proceeding in the code, line 4 is type def, and the name struct phone there, which is underlined in yellow, that's probably the only time you're going to see this. Basically, that is a placeholder, and we're never going to use it again. What we are going to use is the name phone on line 12. That's the type we're defining. What is a phone? It's all these things from line 6 to line 11. It's a character array called color, a float called storage, a character array called size, and so forth and so on. So when we later on declare something to be a phone, that's what we'll get. We'll get all that stuff. So that's the .h file. That's what you'll design in Project 7. That's what you'll attach to your post in Project 7. And that's what you'll screenshot in Project 7 for the first step. Now notice I've got comments out beside, they may not be great comments, but I've got comments beside each member. That's important to let folks know when they try to use your struct what the various members mean. For instance, it's important to know that the storage is in gigabytes. I probably should have named it that way. I did name camera megapixels, making it clear. But if you just see storage, what are the units? Might be megabytes, might be kilobytes. No, it's gigabytes. The comment really helps there. Let's look at where this is actually used, which is in phonetest.c. This is basically my main.c that a lot of IDEs will create automatically for you. So we'll just walk down through this. Lines 3 and 4 are standard hash includes for built-in C library header files that you need. As you know, standard.io.h brings in printf and scanf and some useful stuff. And string.h, which you probably have seen before, brings in functions like strcopy that we will need to put copy data into our structure to essentially assign to character arrays. Line 7 is different. Line 7 is a hash include for phone.h. Hey, that's our file. That's the one we created. A subtle difference that you will notice is that the hash includes on lines 3 and 4 for the standard library files are surrounded in shields, the angle brackets, the less than, greater than signs. Whereas the name phone.h is surrounded by double quotes. That is a convention that means the following to the compiler. It means that when the compiler sees the shields, the angle brackets on the standard library files, it knows where to look first. It goes first to wherever your compiler and IDE got installed, and it looks in there for the files. And that's where it's going to find them. When the compiler sees something in double quotes, it looks first in the current folder, and then it goes off and looks other places. There's a list of places where the compiler looks for hash include files. And of course, it's going to find, it better find, phone.h in the current folder. So by using the quotes and the shields correctly, you make things a little bit easier to find. And actually getting the phone.h in the same folder as your C file is probably the first initial mistake a lot of people make. You have to do that first. If phone.h lives in downloads and your C code lives in documents, that's probably not going to work. Okay, here's a function. We'll come back to that function from lines 10 to 20. Let's start by looking at line 22. It says phone, my phone, bracket 5, bracket. Now, you probably know from other arrays like int arrays or character arrays that the number in the square brackets is the extent of the array, meaning the maximum number of elements that are allowed to be assigned to that array. So this supports 5 phones. It supports 5 instances of the phone struct. That's basically what happens. I'm only going to initialize a couple of them, but you're now seeing an array of structs, which is something that's going to come in, a data structure, that's going to come in really handy as we go forward. Going to need it also in projects in 8 and 9. In lines 27 through 33, I'm populating, filling in, giving values to the first phone, the number 0 phone in my array of phones. And I'm making an Apple iPhone and with 64 gigabytes. Okay. Notice I'm just giving us the name of the, not the name of the struct, not phone, but the name of the instance, the name of the variable, my phone, giving a subscript to identify which element of the array I want, and then giving a dot operator, and then the member name. That's the syntax you use for getting into the array, finding the right element in the array, and then getting into the structure at that element and finding the right member. If you keep the idea that arrays have elements and structures have members, keep that terminology straight, it probably helps you some in understanding these explanations. Okay, lines 35 through 41, here's a second phone of a different type. Same struct, different values. This one's an LG G8 ThinQ. It's medium size and it's black in color. It's got 128 gigabytes of storage. and a lousy 7.7 megapixel camera. That's lousy now. Okay, so now we populated element 0 and element 1 of the array. I could also do 3, 4, and 5. Well, no, 3 and 4, because we started from 0. But I'm not going to in this example. So this is where the array of structs comes in handy. As you may imagine, anytime you have an array, you pretty quickly need to have a loop, a way of iterating through the elements of the array so that you don't have to give inline code 0, 1, 2, 3, 4, 5, which for a structure with all those members would be very tedious indeed. So I'm going to loop here 2 times, 0 and 1. That's the iPhone and the G2. And I'm going to print them out. How do I print them out? Well, that's that function we skipped over before. This user-defined function, you're going to define this for yourselves in Project 7 for your particular struct. And it takes a phone as a parameter. So you can pass that whole struct in, or a particular element of the array of structs in, to a function, and it has access to all the members. So it's going to print the manufacturer, the model, the color, the size, the storage, and the megapixels using the appropriate printf formatting characters. And it doesn't need anything else because all that information came in this parameter. Much more convenient. So if we compile this program and run it, I compiled it before, so I will run it down here. I've just compiled it again. When I run it, we see the data that I put into those 2 elements of that array of structs. You'll see the Apple iPhone and the LG G8. In your projects, you'll probably have like 5 instances, and you'll use a loop to go through them. And in later projects, we'll actually write those out to disk using a method called fwrite, and we'll read them back in a subsequent step. So we actually will make almost a database in a sense that the data gets stored on disk and get retrieved from disk. The data have a structure as defined by the struct. It's rather like a database. So that's basically where we're headed with this. I will post these 2 files, phone.h and phonetest.c, in Canvas so you can examine them at your leisure and learn from them. And the only caveat is that one kind of thing you can't choose to use for your Project 7 is phone, since I've already done it. But your projects using a different topic will be very, very similar. That's it. Thanks a lot. And I will talk to you soon.